Unit 17, simplifying, adding, and subtracting radicals. You've already done a lot of this before, and we are revisiting it one more time, and this time we're going to put numbers in it. So we are going to do a to the 6th. When you do not have, there can be numbers here. If there's not a number, that's a 2, which is a square root. And then 1, 2, 3, 4, 5, 6. And then 1 lives, 1 dies, 1 lives, 1 dies, 1 lives, 1 die. That's a to the 3rd. That's longhand. And there's an implied 2 there because it's a square root. And so they come out and they have to group together in pairs. And so it's 1 lives, 1 dies, 1 lives, 1 dies, 1 lives, 1 dies. And he's left inside. So it's a cubed and the square root of a left inside. There's actually a faster way to do it. Because of this 2 implied, I can take the exponent, divide by 2. So it's a to the 6th over 2, and that gets rid of the radical, so it's a to the 3rd. This one is a to the 7 over 2, which is 3 and 1/2, which means he isn't a pair, so it's a to the 3 under the square root of a. So there's 1 left over, so your remainder stays inside. That's the quicker way to do it, or another way to do it. Okay, so this is a to the 24th over 2, which is a to the 12th. This is a to the 31st over 2 equals 15 remainder 1, means a to the 15th is out, square root of a, there's your remainder. Okay, this is an implied 2. If it was the cube root, you would be dividing by 3. If it was the 4th root, you would be dividing by 4. This is a to the 47 over 2, which is a 23 remainder 1. So it's a to the 23rd. The remainder 1 is sad and lonely, still in the radical jail. Okay, like we did this earlier, you deal with sign, you deal with numbers, you deal with letters. So square root of a, and I can split this up, square root of 81, and square root of a to the 4th, b to the 6th, c to the 10th. Square root of 89 is 9. A to the 4 divided by 2 is a to the squared. B to the 6 divided by 2 is b cubed. C to the 10 over 2 is c to the 5th. And that would be your square root. If they're not perfect, so say I have the square root of 27, and I can break that down into 9 times 3, which I can break down to square root of 9, let me erase that, times the square root of 3, which is 3 square root of 3. So you're going to factor stuff out. You're going to factor perfect squares and leave lonely ones inside. Okay, continuing on. I'm going to rewrite this as the square root of 25 times the square root of 3 and x squared y cubed, and that should get me good enough because I factored out a perfect square. So that's 5 square root of 3 and then that's x, and that's y square root of y, because that's 3 divided by 2 is 1, remainder 1. Okay, now I'm going to gather my coefficient and my variables, 5xy square root of 3y. And this is the format. So make sure it's number, variables, inside radical, numbers, variables. Okay, here's 3, square root of 121, square root of M4N5P7. This is 11, so that's 11. So that's 3 times 11. The M, 4 divided by 2 is 2. N divided, or 5 divided by 2 is 2. Oops. 2, remainder 1. 7 is 3, remainder 1. Rearrange. That becomes 33 m squared n squared p cubed. Radicals are n and p. And this is your final answer. Okay. -5 square root of 18 x cubed y square root of x to the 5th y to the 6th. This is 9 times 2, and square root of 9 is 3, so this is -5 square root of 9 square root of 2 x cubed y square root of x5 y6. That's -5 times 3, which is -15. Square root of 2 has to stay there. It's going to come back over here. X cubed, but then this is x to the squared with a square root of x inside. And this is y cubed. So 2 x's and 3 x's becomes x to the 5th. 1y and 3 y's becomes y to the 4th. And remember that we still have a square root of x. So this is your answer. I'm going to split this up. I'm going to do it in a different color so you guys can see it a little bit better. So this is square root of 363 over 3, and that's all under one radical. And then it's also x to the 5th over x and y over y cubed. 363 divided by 3 is the square root of 121. X to the 5th over x is the square root of x to the 4th. 1 over y squared. This is 11. X to the 4th comes out as x squared. 1 over y squared comes out over just the 1. And it stays in the denominator, and that is your answer. Okay. They have to have the same square root. Okay, so if you have 4x plus 5x, you get 9x. Instead of a variable of x, we're going to have a radical. If the radicals match, then you can combine them. So just like if you had 4x plus 5y, you had to leave it as 4x plus 5y. So look at these as variables. 4 square root of 7 plus 5 square root of 7. Add the coefficients, take the radical. Now you can manipulate them so they will look the same. That's the whole purpose, is we're going to get them to look like the same. Square root of 11, square root of 11, they're the same. 8 minus 2 is 6, square root of 11. Okay, these do not look the same, all of them. There's nothing I can do with that because that's a prime, but I noticed that square root of 6 and square root of 6 are the same, so 3 square root of 6 and 5 square root of 6 is 8 square root of 6 minus 2 square root of 13, and that's actually your final answer. You cannot combine it, and when you are simplifying radicals, you are not giving me a decimal answer. Okay, 9, 10, 11, 12, Okay, so these don't have the same thing. I'm looking if this is divisible by 3, which it's really cool it is. So it's 5 times 3 times, I'm going to do 192 divided by 3, which is 64. Ooh, yeah. Minus 7 square root of 3. Notice that's an 8. So that goes 5 times 8 times square root of 3 minus 7 square root of 3. 5 times 8 is 40 square root of 3 minus 7 square root of 3. Now my radicals match. That is 33 square root of 3. And that is your final answer. Do not put it as a decimal. Okay, let's look at this. I know that 25 square root of 2 is not going to do anything because 2 is prime. I know that is 2 square root of 9 times square root of 3. And I know that is 9 and 17. Can be divisible by 2. So that's 2 times 49. Ooh, love that. Okay, so that's a plus. So that stays 25 square root of 2. He's not combining anybody. That is 2. This becomes a 3 and square root of 3. Oh, that's nice. And that's 3. And that's a 7 square root of 2. Oh, nice. So that's 25 square root of 2 plus 6 square root of 3 minus 21 square root of 2. Awesome. Like radicals, 25 minus 21 is 4 square root of 2 plus 6 square root of 3, and that is your final answer. So it will help you if you know your perfect squares and your factors. So notice all I did was split up 27 into the square root of 9 times the square root of 3, and then that's a perfect square. I knew that was even, and I liked that that was a square root of 2, so I was hoping that somebody would come out and a perfect square of 49, which becomes 7, came out. Then once the radicals are alike, you combine through addition or subtraction. This is addition and subtraction of radicals. Make sure you understand that because multiplication of radicals is totally different.